So I'm going to be playing the sound again.
Humans have never stopped exploring and surveying the Earth. The human history has witnessed a constantly advancing science and technology. A wider scope of surveying becomes possible, and the accuracy is constantly being improved. The marvelous progress of surveying has been changing the way people understand and create the world. We are Tersus GNSS, committed to improve the life quality of everyone in the world. Our robust products and affordable centimeter precision solutions transform the workflow and make it more efficient. Equipped with in-house designed RTK boards as well as advanced signal processing technology, Tersus GNSS systems provide you the unprecedented flexibility and accuracy in the sky, on the land, in the ocean. Wherever innovative positioning applications are needed, you can rely on Tersus GNSS for continuously accurate and real-time positioning. In Tersus GNSS, every day, we are inspired and motivated to push innovation to the limit and have it realized through our intelligent workshop. Based on GNSS, Tersus products are empowered by its own technology with integrated wisdom of skilled professionals. Fully independent in R&D, Tersus's products provide assured, accurate position. Our latest RTK system, Oscar GNSS receiver, provides accuracy less than 2 centimeters. Not only do we deliver high precision products, we strive to deliver perfection. By 2021, Tersus products have been favored by users in more than 90 countries and are stepping up to reach more regions worldwide. A great news, Tersus GNSS wins the largest order in Nigeria with 185 Oscar G. We are chosen by the experienced. In the era of intelligence, everything is connected. Tersus trusted GNSS solutions link the information and the globe. Unlimited value is created.
So I played it again. I just want to be sure. Did we hear the audio?
Yes, sir, we did.
Yes.
What about the video?
Yes, sir. Yes, sir.
Oh,
Yes.
okay. I did not even know. Oh,
The
perfect.
video is okay
Perfect.
too.
Perfect.
Yeah, we had the audio.
So let me reshare.
Yeah. Welcome to Geospatial Night, where data meets precision and knowledge becomes power. With the GNSS King. From the ground to the sky, yeah, we map it all. Satellites above, hit system call, board and it's locked. Every point precise from Lagos to the world. Yeah, we set price, RTK flow, centimeter dream. Force on the network, tighter than it seems. Leader in the air, scanning every plane. Turning point clouds into insight, getting aerial vision. We don't get, we know. Photo imagery make the model flow. From construction site to the curve we grit, we define the future. This is how we live from beginning to end. Got the story to tell. From the earth to the orbit, we read it well. Elevation rising, no limit. Stuck. Get ready for the knowledge. Get spatial night. plane, yeah, we model the ground. DTM accuracy, got the message profound. UAV flights, yeah, we capturing truth from the pixels to the points. That's the power of proof. Surveillance, engineers, planners align, oil and gas, agriculture data redefined. Smart cities popping with geospatial core. Every industry knocking on the data. Go from Bay image to down to the skyline view. Every day set clean, every upper truth. GNSS King, stop the inside kitty, unlocking global geospatial mastery. See the world in coordinates. Every line tells a story. From the ground up, we elevate, turning knowledge into glory.
Welcome to Geospatial Night. Welcome, everyone. Welcome. Welcome is another interesting session. And I am still your host. I am your host, Chika Okorocha. It's a pleasure to be here. So like we said, if there's anybody you know that should be here and has not joined us, you can just share the same link you register with. The person would register and get the Zoom link in the email to join. So I'm excited to be here for another session, and this promises to be very interesting. Remember what I said? Towards the end of the session, I'm going to be sharing an offer that will be coming up during the AGM. But what you'll be getting this night is different from what you have during the AGM. It's much more better. And that's why I said it is a closed meeting for only those that are live. So remember again, you can share the same link to your friends that should be here and they are not yet here, that we have started and we are already live. Once again, I'm Chika Okorocha. I'm welcoming Jubril, welcoming Hamzat, I'm welcoming Nuruddin. Abidemi, you're welcome. Abdullah, you're welcome. Solvemap, you're welcome. Dr. Hassan, you're welcome. God's Power, you're welcome to this night. Adisa, you're welcome. Olamide, please pardon me if I'm not adding surveyor, I'm not adding doctor, I'm not adding fellow, I'm not adding all the titles because of time, but please, I want to try and welcome everybody as much as I can. Olamide, Philip, you're welcome. Samsung SM, you are welcome. Akolade Yusuf, you're welcome. Techno BG6, you're welcome. Captain Comfort, you're welcome. The new user, you're welcome to this night. Abdul Ganyu, you're welcome. John Kenny, you're welcome. Bola Tito, you're welcome. Ogo, you're welcome. Okepita, you're welcome. Emmanuel, you're welcome. Ezra Maga Okoro, Sovio Komo, you're welcome, sir. Kodri, you're welcome. Rosaline, you're welcome. Bam, Bem, Abel, you're welcome. Nkechi, you're welcome. Moses, you're welcome to this night. Oseni, you're welcome. Akin John, Sovio Idiong, Sovio, you're welcome. Avose, Olumide, Isaac, Zaomi, Ademola, Sovio Mohammed, Chukudi, Sovio Taiwo, Sodimu, you're all welcome. Uncle Johnson, I can see you, you're welcome. Abdul Kadri, you are welcome to this night. Sonny, you're welcome. The Pool, you're welcome. Theophilos, you're welcome. Sodimu, you're welcome. And every other person, permits me if I've not called your name during this session, I'm welcoming everyone. Please, if you can hear me clearly, just type in the comment section, I can hear you. Let me just be sure that we are all live. Type in the comment section, I can hear you. I'm looking at the comment section now to be sure that everybody's here. I can hear you. So I can hear you. Good. So why I needed us to type this is so that I know when it is a personal internet issue from my side or from somebody else's part. Because you know it's possible somebody might say it's not hearing clearly. So if I'm getting a lot of I can hear, that means the sound is good and the audio is good, the video is good. So that's fantastic. So good. We're having a good time now. So I'll be sharing my screen. I'll be sharing my screen for the presentation proper. So great. Can we see the screen now?
No. Yes.
Yes.
Okay.
Oh, great. Okay, great. Yes, yes, I can hear. Bam, yes. Can we have more yes? So I'm just sure. If you can see the screen, you can see my slide. Yes, I can see the screen. Yes. Oh, perfect. You are good. So tonight we are looking at CaptureRTK. There's a little typo in this spelling on this slide. It's actually CaptureRTK. There is no RE before the RTK. It's so CaptureRTK. So this is the latest evolution in the GNSS space, I would say. So this is the latest evolution. The idea that your GNSS receiver now have an eye. Not only does it have an eye, but you no longer have to think about taking only single points with the tip of the pole. But now, with the camera on the receiver, you can capture an entire scene. And not just picking a point, a laser point. That is very limiting. Even those receivers can do that now. But now, your entire scene can become a point cloud, meaning you can just take a walk around. And joining me today is Hamzat. Hamzat Abdullah is going to be at the point in this presentation. I'm going to be inviting our project manager to show us some video. I'll play some video, and he's also going to show us some video and some processing we have done. And with that, you can ask more questions. So the idea is your GNSS rover is now a tool that can capture point cloud. And this is an era of building information modeling. It's possible you might not be able to have a full scanner, but you can have an entry receiver that can become a scanner for you. And that is why we are here tonight. So RTK Rover with real-time 3D point cloud generation. Even during the AGM, I have a technical paper I'll be presenting that also go in detail to talk about the level of accuracy we have done in relation to terrestrial laser scanner. But that's not for this session. Maybe during the AGM we'll have that, and possibly for those that might not be at the AGM, we might have an online session in that week, focus on my technical paper for those that might not be physically present during the AGM. So let's begin the session. I'm trying to see, just let me know. I'm trying to see if I can just have a full, share my full screen. So for now, I'm sharing my full screen. Is this better?
Yeah, it's fine.
Okay,
Yeah,
this
it's
is
better.
fine. Okay, this is better. So let's maintain it this way so we have a clearer view. So we'll be going through surveying challenges, efficiency and accessibility, the idea of visual positioning, the tools that can perform this feature, and what to expect on field. Then in the point of use case scenario, practical example, I'm going to invite Hamzat to carry on that aspect and show us some video. So what is the idea? What is the situation now? Now, surveying challenges, and the whole idea of surveying is efficiency. A surveyor, an engineer, a GIS professional that want to achieve high level of accuracy for engineering projects, construction projects, want to carry out the project as fast as they can with the tool available, but also saving costs. So you want to be fast, you want to achieve the same level of accuracy, maybe within 1 cm or 2 centimeter, but still you want to save costs. How will you do that? But in reality, there are some areas that are inaccessible. Conventionally, you go with a rover pole, you could get to some points that you can't go into. Possibly you want to pick high-rise building, some point on the high-rise, and you might need to go back and start using a total station. But we are saying there is a solution. Inaccessible hazardous area like rooftops, trenches, or busy roads. Those are issues. Traditionally, what do you do? Point by point. You have to go and pick the points. Everywhere you want to acquire the data, you have to be at that exact point. So vertical pole limitation. Difficulty in maintaining a perfect vertical pole. Yeah, there are some situations where maybe there are some people that don't have calibration equipment with very high level of tilt compensation. They might be having that difficulty to hold the pole vertically, or you are trying to raise. I know there's this thing we used to do at times. We'll raise our pole to the very top of where we want to observe, and maybe your pole cannot even get to that point. So this is where the solution now comes in. Please, can you still see the screen?
Yes.
Yes, we can see it.
Okay, so this is where the solution now comes in. So the need for integrated data, the need to bridge the gap between raw coordinates and actionable visual context. So what we are saying here is, now the surveyor has grown, or the geospatial professional has grown beyond just showing points. Sometimes they need you to build a model of a building. Sometimes you might be required to compute volume of earthwork. And what would be the fastest way to do it? It is no more an era of you just showing XYZ. Can you build a model in form of point cloud with even a receiver that is very, very cost effective? So visual positioning, or the idea of seeing is believing, is the concept whereby we are saying receivers now have an eye. Clear, concise definition of visuals. So every scene you capture with your GNSS receiver is not just a photograph, but now they are geometrically corrected images. So when we say geometrically corrected images, we are saying every point you pick on that image has a coordinates. Just like what you're seeing here, the image you're seeing there. Look at a high-rise building of about 7 floors, 8 floors. You just capture a scene, and every point you click on that image has a coordinate. How does it work? Camera-based data capture, image processing, feature extraction, and position determination. But the interesting thing about this is you can do this completely on the field. But if you want to have a better visual, you can export the point cloud from your data logger into your software you now process and provide the total visual. So, and what is required? We require a GNSS receiver with a camera. We also need the role of initial measurement system, IMU, because these receivers are capturing this data not in static mode. You can actually just walk and it captures the entire image. So your receiver needs a visual capability. It also needs the camera capability. And receivers we have that can do this. Currently, we have 3 receivers that can do this. We have one, the Oscar Trek. The technology and the performance are all the same. So the Oscar Trek, we have the TS21, and we also have the TS30. Towards the end of this video, this presentation, I will talk about the difference. And the idea behind them is, like I said, camera combined with IMU and initial measurement system, and we now have measure what you see. So this is the core philosophy. It is no longer measure where your receiver can observe. It is no longer measure where your pole gets to, but it is measure what you can see. Meaning I can stand about 15 meters away from a building, and as long as I can see at 15 meters away, I can capture an image, and every image there has a coordinate and can be generated and transformed into point cloud. Work confidently with a tilted pole and in motion. This is very important. At this point, now look, if we compare it with traditional GNSS pole, where you have to observe everywhere you get to, this one changes the entire thing, because you no longer need to get to that point to observe. Rather, you simply just capture a scene and you generate the coordinate from there. And what's the capability? This is working because these receivers, the 3 ones I mentioned, has 1,792 channels. So the amount of satellite they can track is optimal, and it's tracking all the available constellation. It's integrated also with tilt compensation, and the calibration level is completely free, meaning you don't have to keep calibrating. The moment you set up your receiver, you move. How can it work? You can work either with the base station, you can work with the core station, and you will still perform the same function. So like I said, GNSS receiver integrated with camera, tilt compensation becomes a game changer in this industry. Now look at what you're seeing here. And at this point, permit me to share a video after a part of this presentation. So we have HD camera on the receiver that captures detailed images of the target area. Now we are not saying capture detailed images of the target points. No, detailed images of the target area. Now the IMU, the integrated IMU, provides what? Orientation and tilt data. Meaning it doesn't matter the angle of inclination of your receiver to the scene. As long as you can capture that entire scene, you can begin to generate coordinate like what you see here. The power combo, photogrammetrically pick multiple points from a single captured image. Key benefit: drastically reduce field work time. measure dangerous and inaccessible points from safe and convenient zone.
Comfort zone is a psychological state where things feel familiar, safe, and low stress because you aren't being challenged. Growth usually happens just outside of it.
So what's the level of accuracy you can achieve with this? In real time, you can achieve about 8 centimeter level of accuracy. Now, this is if you are carrying out your normal RTK measurements. RTK measurements, this one depends on how close you are. But while we are using this visual measurement system, we can achieve between 2 to 4 cm level of accuracy, depending on the distance you are away. And the idea is because these points are not points you go there to observe. That is why I would say even if you are getting 4 cm, when you are about, now this is showing 10 cm, we've tested up to like 15 cm, you can still achieve 15 cm. When you use the TS30, you can still go away 15 meter, 15 meter away from your position, you can still achieve around 4 cm, 2 to 4 cm level of accuracy. And look at this application area. Areas where you would not necessarily go to peak. Look at the edges of a bridge or the top of a building. You can capture that scene and provide the detail needed. So engineering surveys, as-built and construction stakeouts, this can be done. Mapping and GIS. Now, I would say for mapping and GIS, this would involve you building a model of the future of interest, and you generate as many points as you require. Infrastructure inspection. This is done. Points you cannot reach, roof corners, building corner, mining and volume calculation. This is very, very important. We're going to display a video where this is done. And models like this can be generated directly from your GNSS receiver. How is that done? Just like the principle of photogrammetry, where you capture overlapping images. When you walk around the points of interest, let me play a video, then I'll come back to this slide. I think that's very important. Permit me to play a video now. Can we see my screen? What can you see? Please type what you can see. Can you type what you can see? It's written. Let me not mention it. Let me be sure we can see. Can you type the text you can see? Correct. So we can see it. Great. So let me play the video now. Just a second view. So what we're seeing here, this guy is just taking a walk. And as it takes a walk, it captures the entire scene. And it can now zoom onto his data logger and pick the coordinate of any point he's interested in. So that's why I said this is better than a laser. Laser, you need to target a point of interest. But here, you just take a walk, capture any scene, and zoom into your data logger and pick the coordinate. The same thing. You just take a walk, capture the entire scene, zoom in and pick, as opposed to when you need to walk to the point of interest and pick. So that's what you're seeing here. Look at the contrast. You just take a walk, you capture the entire scene, just like laser scanning, rather than going to each point to pick the point. So this is increasing your level of efficiency over 30%. With this, you are able to capture points that would have been difficult for you to even capture before now. So this is the advantage of visual photogrammetry. This is the advantage of GNSS receiver with a camera, not just an ordinary camera, because we have receivers with a camera that cannot perform this. Such cameras are only used for visual staking out, but they cannot perform geometric corrections. They cannot perform building of point cloud from those images. So it's important for us to take note of that difference. So let me come back to our, let's return back to our presentation. So we are back to our presentation. So this, for what you've seen there, that's just what I've been explaining. You capture the scene, and every point in that scene has the coordinates. You only zoom to the point of interest and it generates the coordinates. And from there, you can convert that entire images into point cloud. And that point cloud leads to building model like what you're seeing here. So back to the application area. Benefits and value proposition. This increased measurement efficiency. By capturing many points in an image, field work time is reduced. Access to difficult location. Reduced need for conventional pole leveling. It reduces that needs. We can integration with 3D modeling workflow. Seamless integration with 3D modeling in either CAD software or GIS, meaning we can take this to a GIS environment. We can even take the point cloud to architectural environments, just like Revit. The point cloud can be taken into Revit, where you can go further and build digital twin and 3D model if you have that skill and ability. Enhance safety. We've talked about enhancing safety. In hazardous area, we can go there and capture the points of interest. Improve data confidence, high accuracy in real time with visual verification. So you can see it's not just enough to provide your client with points, you are providing your client with point cloud, and your client can have a visual understanding of that area. This also will reduce the total cost of operation, because you just have a single man that can just move around, capture the entire scene, goes back to the office and generates all the points of interest. And now this is what is possible. The image on the left is what was captured using this camera. This is a section of our building in Lagos. And what is the workflow? Step number 1, set up a base station or core station. Step number 2, your rover unit is deployed, connecting to the base, a local base, or a core station, and you just move. Your operator aims camera and captures the image. Then you pick the points of interest. And from there, you can export your geotag picture or you export your point cloud. So that is how fast it is. You can do a quick survey and generate a sparse point cloud, or you can actually build a dense point cloud, depending on the point of interest. And if you want the point cloud to be dense, you can have multiple capturing of the scene. Just the same way we do photogrammetry, you fly your drone, and once you increase the level of overlap, you are going to have a denser texture and a denser 3D model. So it's the same way. And not just that, remember I said we now have receivers that have the capability for longer range. So currently, we started with the Oscar Trek. We now have the TS30, that with the TS30, it provides a laser that can go as far as 50 meters to capture a point. So the TS30, I will talk about those differences much more later. The TS30 is our latest solution that you can stay as far as 50 meters and capture any point of interest. So with the TS30, you can go up to 15 meters and capture an entire point cloud. Or if you even want to go much further, your interest is just single points, it still have a laser that can go as far as 50 meters and still give you 8 millimeter level of accuracy. So this is what is possible today. So we have receivers that are operating like a laser scanner, receivers operating like a total station. And how is that possible? Because we have high precision laser ranging. So can we mute ourselves, please? Let me try. Okay, yeah, to mute everybody. So let me go on. I've just muted everybody. So the laser, like we mentioned, can go even as high as 50 meters. And what we've done here is to show some level of comparison. And what we are saying is we can have up to 3 centimeter level of accuracy. And when we did some comparison, we realized that some other competitors have laser, and with their laser, competitor A, competitor B, competitor C, and competitor D, we look at all this and we are seeing that we are having better performance. So we try the competitor A and we are realizing that we are having better performance than them by what you are seeing on the screen. For the purpose of this presentation, we are not showing we are not naming the competitors, but we are letting you know that our latest technology has even much more better performance than what you can see in the markets. And just like what we said, the visual slam, this scene you are seeing here is just showing us what happens. When you walk around it, it builds sparse point cloud of the environment and track visual feature in real time. So as the rover moves, the surveyor moves, what you see on your left and the right are just sparse cloud that can be captured. So from the sparse cloud, that is how the technology is able to perform long ranging, laser ranging. It uses the ability of the visuals and uses that visual to generate point cloud, and the point cloud is also able to hit the target feature of interest if you're looking at the laser feature. And what we are showing here also is the level of point cloud that you can get using this technology. This is just a feature, and this was not done with a laser scanner. This point cloud you're seeing here was captured using a GNSS receiver. We can also go on to do what we call AR stakeout, because these receivers have dual camera. The dual camera allow us to perform visual and video-based stakeouts, meaning you are carrying out your stakeout and you are seeing like a video of where you're going to directly in your data logger. And what we're seeing here is what I've discussed before. The entire scene, not just single points, but you can stay at a distance and capture an entire scene. And every point you are interested in, you only place a click and the coordinate of that point comes out. So at this point, Hamzat, I'm going to invite you to carry out some practical demonstration of what you have done. Hamzat, are you there? Before we go into the next section. So Hamzat will take us on the second section. From the second section, I will go to the last session. So the last session will talk about the various products and the special offer we have for the AGM and for everyone that is live here. Hamzat, are you ready? Okay, great. You can unmute yourself.
While I try to use my screen, so you can share my screen. You need to do that.
Your audio is not very clear. Type a message in the comment section so I
Kika, is Hamza asking for permission to share his screen?
Yes, I've made him host. Hamzat, you are host now. Hamzat, are you there? You are host. You are now the host.
It's my screen now.
Yeah, yes, we can see your screen, but it's dark.
Right now.
Yes, sure, it's fine now.
Presenting for a people that size on your starting. Showing visuals of the intersection, right from the field to the software application. Then I will explain in details of the so I'll break it down in the field acquisition, down to linking it to the correlation, down to the software used for the processing aspect. So in case you have any questions afterwards, you can also address that as well. So Sabatika has explained the entire process to us already on how to go about I'll play a video for you on the sites. So all you want to do is So in this step now, we are just taking points around the entire field that we had on site. So all these points are coordinated in X, Y, and Z coordinates referring to the core station. These are pictures from the field exercise that were doing on software. Once you pick up several points within the same several pictures, we having them available. You can see the use tracks there, 10 images with their coordinates, X and Y coordinates. So now we are doing the dense point cloud now. A sample of the model that was shared by Tersus earlier. So you use those entire images that were took on site and use them to build a dense cloud model for the entire area. So hold on for the process. And that's the dense cloud you are seeing now for the entire area. And export the dense cloud in format of .las for the format. Now moving on to display the features inside the folder. Copy this and move into the software aspect. So we're using the Road Architecture Studio for the processing of this session. And then we'll create a new job and then import our last file and see the visual of the entire last that was scanned on site. And on here now, you can also generate X and Y, take linear measurements on the across the entire board. This is a visual of part of our office building, a part of it. And this is the reference to the real ground position. So that's a linear measurement being taken on ground. You can as well then take coordinates of points inside this feature. Instead of us having to be on field to go with TS and pick every point, window level, whatever you want to pick on the field, and go scan and then come back and get your entire point cloud of your entire area, without having to go back to field anytime you go back to field. And any additional feature that's required by the client, you don't have to return back to field again to do them. You can as well just from the feature, from this, just coordinate and then put them on your own card. This is an advanced system that helps solve problem of having to return site every time you have to capture data. The full scan can have an entire data from the entire work area. The data from this cloud can be generated to Excel or to CSV file for the points generated. And then you can also confirm them with ground points to see if they are true values. These are what we confirm to see the accuracy level that we had earlier shown by Geospatial. So for 3 cm for every 10 meters. So this is the entire video. So these instruments are available for use for all sorts of survey, both for scanning, both for building building jobs, and also for any feature that you have to identify on ground without having to be there. So it's incorporating photogrammetry into a system and then help us to work in the case of like a Tersus data scanner. So this what I see here is not from a drone or from a scanner, it's from a GNSS system, and it works all the way down to our results. So thank you for this session. And if you have any questions on this session as well, you can also make your questions. Any inquiries can be also directed to this so the mail that was shared with you earlier. Thank you very much. I want to watch my boss and so she can continue the session.
Hamzat, can you make me back the host?
Yeah, on that, sir.
Okay, I've reclaimed host back. Don't worry, I've reclaimed hosts. So that's just to play that video he shared again. Maybe for those that really did not get the sound clearly. Please, can you just confirm you can see my screen? It's written, tell me what you are seeing there. Just type what you're seeing on the screen. Warning. Okay, great, great. So let me just play this video. Because I could see some people saying the audio was not too clear. So I'm just going to play this now. So that's just how we move. That's Hamzat and our colleague just moving. You just take a walk. What you're seeing on the left-hand side is what is going on the receiver. That's how you just walk. You capture all around the building. Visual points. Zoom to any point of interest. Once you zoom very well, see that's not a particular point, the corner you're interested in. So you can zoom to a point and pick, or you choose a sparse point cloud and it generates point cloud. So this is what we actually did. So the interesting thing about this is anybody getting this solution has free training to be provided. So we provide free training. If you choose the dense point cloud, the cloud is denser. That's point cloud. Visualizing the last file, which is the point cloud. So you can use different software for this, even photogrammetry software like Agisoft, Pix4D. You can do that. Cloud Compare, you can do that. So what you are seeing here, this is just a quick scan. So if they had done multiple scan, every detail will be showing. And you can take measurements, you can do your dimensions, generate your as-built drawings directly from the scan. So you can pick points, you can take measurements. Look at Aristo, look at Delta Clinic, even some of the labelings are even showing, and they're all generated from points cloud. So if you take your time to capture, a lot of details can come out within the software environment. And from the software environment, you can generate 2D drawings out of it. So, and that's the end of that video. Let me stop it and come back to my slide. Let me return back to my slide. So I'm back to my slide. So with this, we've come to the end of 2 sessions. And now somebody might be asking, what is available? How can I get this solution? How is there a special offer? Remember I said when we started, before I go into the question and answer, I said there is a special offer for everyone that is coming live. It could be from the least option of the GNSS receiver to the highest option. And the first option we have in our list here is the Tersus Looker base and rover. Normally now we sell the Tersus Looker at 2.9 million. That's the current price of the Tersus Looker. The Tersus Looker rover system, sorry, it's not base. Rover system is 2.9 million. It's single rover. You are having TAP. TAP is the Tersus Advanced Positioning Service with 1.5 cm accuracy. That is now free on this promo, and you are having a 400,000 discount on it for the AGM. What you will get at the AGM is a little bit higher than this price. So this is a special offer for those that are here live, and you actually do not need to pay all at once. You can look at making a deposit of at least ₦1 million. So we retain this offer for you. So this is the Tersus Looker going for, this does not have the visual photogrammetry that we've talked about today. It doesn't have that. So this is the Tersus Looker, and what it has is the tap service for 1 year free. You are going to enjoy that free for 1 year, and it's just a regular receiver with an inbuilt battery. So you are having this as the first offer we are having. The second offer for you is a base and a rover. If you are getting a base and a rover of the Tersus Looker, that is 6.5 million currently. But the offer we have is 5.6. Even at the AGM, you won't have this. And like I said, to retain this is just a minimum of 1 million at this time. You have just 1 million to pay. Just 1 million you need to pay for this. This is still Looker. There is no visual photogrammetry ability on this. Going further, when it's time for question, I'll move back and forth. Going further, we have the Oscar Ultimate. Both the Tersus Luca and the Tersus Oscar has tilt compensation now. The Luca has 60-degree tilts, while the Oscar have 90-degree. Also, you have the tap service free for you, and a single rover is 3.9 million, but the special offer is 3.5 million. Sorry, I think I am mixing something. Yeah, 2.5. Yeah, this 2.5. Why the Oscar is 3.5. 3.5 million for the Oscar. 3.5 million. If you are going for the base and rover of Oscar, which is 8.8 million, currently we are having a special offer for 7.5 million. Can you imagine that? That is 1.3 million less. This is a special offer, less than the AGM for the Geospatial Night. Less than the AGM. This is, you won't see this at the AGM. You won't see this in any of the price lists we are giving. But because this is an AGM season, we are having a special offer for those that attend our live session. And that is why you are having the 7.5 million. Now we are back to the equipment with visual photogrammetry point cloud ability. The Trek, which is the first option, goes for 5.8 million. The single Trek that can perform point cloud generation. This is more than a GNSS rover. This is a surveyor going into building information modeling. Free training will be provided, and you are saving 1.6 million naira tonight. And you are having this for just 4.2 million only. This is special offer for you. And the higher one, this one does not have the laser, but it has the camera and can do visual photogrammetry. The option that has both laser and camera, dual camera, is the TS30. The TS30 is 6.8 million, but the special offer for it is 5.2 million just for this Geospatial Night. So if you are looking at this and you want to ask question, it is time for us to go into the question and answer session. And these are the special offer you are getting for joining us tonight. And now I would like to take the question, and the account number has been provided in all category. As you're looking at the screen, you have the account number there. You can make a deposit of at least 1 million naira to retain this offer. A deposit of at least 1 million, and you will not get this even at the AGM. You won't get any of the prices we are showing you tonight, even at the AGM. So now it's question time. You can drop your question in the comment section, and I will begin to answer the question. The question can be about the prices, about the offer, when can you make your payments, also how can the training be carried out if you are not in Lagos. We'll provide the answers. This can be very useful for facility management and monitoring. Absolutely. That is the idea of visual photogrammetry. This is not an era where you focus on just single points. This is an era where you go into point cloud, capturing multiple point cloud, generating multiple point cloud, and building models out of it. It's time for question. I'll be looking at the comment section. If you want to speak, you can unmute yourself, and it will be your time for you to speak. So let's go. I'm looking at the comment section. You can drop your question in the comment section. Also, you can drop your question in the comment section. You can make a deposit of at least 1 million naira on any of the options we provided to retain the offer. You can even make the comments and call me. You can make the transfer and call me later for us to focus on which of the products you are going for. Once again, I'm looking at the comment section. I'm going through all the options. The list you have tonight is only 2.5 million. instead of 2.9 million for the Oscar Looker. With this, you have access to over 20 course stations we have currently in Nigeria using the SOCPOST mobile app. We've talked about the SOCPOST in a different session. So currently we have course in over 22 locations, actually, over 22 course. And with the SOCPOST app, you use just a single rover and you begin to connect to those course stations in real time. So even if you don't have the resources for the visual photogrammetry tool, you can even get any of this. So I'm looking at the comment section. Please let the questions begin to come. Any question tonight? The account number is there. So this is the Tersus Looker Rover. This is the base and rover, a full set. Base and rover with external radio for 5.6 million only. You are saving 900,000 with this one, 5.6 million only. And the one with the base and rover, Oscar Ultimate, that one is 7.5 million. The one with the visual photogrammetry feature, the Oscar Trek, that is 4.2 million instead of 5.8 million. Then the one with the TS30 with dual camera visual photogrammetry ability as well as laser scanning. Laser like a total station. That one is 5.2 million. Any question? If you want to speak, you can unmute yourself. If you want to speak, you can unmute yourself, or you can drop a question, a question in the comment section. You can ask question in the comment section and I would read your question. You can ask, you can unmute yourself and ask, please. The offer is still on. Can you hear me, please? I want to be sure we can hear me. Can you hear me? Please, if you can hear me, say, I can hear you. Hope I'm not offline. Okay,
yes,
good.
You can hear you very well.
Okay, someone is asking list of software you can use for processing point cloud. So for point cloud, you can use Pix4D, you can use Agisoft Metashape. We have our own Tersus software that you can use. Tersus have a software for point cloud processing. You can also use Cloud Compare to process the point cloud. Actually, the point cloud is generated directly from the receiver. So it's not like you're processing it separately. So I would just say for visualizing the point cloud. So you can use all those software for visualizing the point cloud, because the point cloud comes out directly from your data logger. Once you export the point cloud from your data logger, you can now take it into the visualizing software to visualize and convert to any other format you're interested in. Do we have any other question tonight? Any other question? Either on the presentation, the application, or on the offer we're providing. Yes, for training. The training, like I said, is free. The training is free. But for the purpose of location, the only thing you are going to handle is the logistic, because we don't know where your location will be. If the training will be in Lagos, it is completely free. You're not paying for logistic. But I don't know where you would be if you are any part of Nigeria. The only thing you would handle is the logistic of our team coming to your location. That is what you would handle. We are going to pay for our hotel accommodation ourselves, but the logistic that involve the transportation, that is the only thing you would handle, because it depends on the location where you want the training to be. But when we get to that location, we'll pay for our hotel accommodation ourselves. So like I said, going through the offer again, like we provided, the first one here is the Tersus Luca. The Tersus Luca is 2.9 million, but currently is going special offer at 2.5 million. We have the full base and rover at 5.6 million. We have the Oscar Ultimate, that is 3.5 million, and we have also the full base and rover Oscar Ultimate for 7.5 million. We also have the Oscar Trek, which can carry out the visual photogrammetry, point cloud generation, BIM modeling for 4.2 million instead of 5.8 million. You also have the TS30, which is the latest visual photogrammetry tool. This one can perform both laser scanning, visual photogrammetry scanning, as well as laser measurement like a total station. And this is going specially for 5.2 million. And that is all for this night. Any other question?
Hello, Chika, can you hear me?
I can hear you, sir.
Oh, good evening. Thank you so much. I think the network was not too friendly, but we get the gist of what you are trying to do. Now, I want to ask just a simple question. From the illustration where you show some persons taking a photograph, taking a photograph over the area, and through the data logger, we can see where you now, they move to the point where it's of interest to them.
Yes.
I want to find out, assuming it is a story just like we have seen up and down. So those points that they are extracting from there, are they points that have been corrected? That is the coordinates you are getting. Is it with reference to any other, assuming if you go there with your rover and get them, is it something that you have the same, or is something you need to convert again?
Yeah, that's a good question. So the idea is every point you are generating, that's why I said is geometrically correct within 2 to 4 centimeter accuracy. So there is nothing else you are doing. When you just walk, that is why we are saying you are able to access in places you cannot, inaccessible area. Once you capture the image, you zoom there, you click on it, the coordinate is generated within 2 to 4 cm accuracy.
So how do we now validate? Let's be sure that truly it is what it is.
That is the function of the equipment itself. So if you want to validate, and now talking about validation, that is where I said the presentation I'll be making during the AGM talks about the validation. There we compared total station, laser scanning, and visual photogrammetry to provide the difference in level of accuracy. Because it is corrected with a base station or a core station. Remember I said your rover is not working alone. Your rover is receiving correction from either a base or a course. And that correction is what is transmitted in the visual photogrammetry operation to generate the coordinates of those points in the images. Do you understand, sir?
Okay.
Yes, so its correction is coming from the base station setup or the core station the rover is receiving the correction from.
Okay, thank you. That's fine. That's fine. So
Yes, sir.
we hope to see that this thing in the AGM. However,
Yeah, during the
better
AGM, we are going to be having practical demonstration of both laser scanner, the visual photogrammetry tool, and everyone coming there would experience it firsthand. Any other question?
Fortunately, I won't be there. That's just the sad
No,
story of
now the
it.
good thing is, like I said, during the week of the AGM, for those that will not be there, I'll also be making a presentation online.
All right.
Not that, just like what we're having here. Of my technical paper, I'll be having it online also to talk about the accuracy level that we're able to achieve.
Okay, thank you so much. I appreciate it. That's fine.
All
This
right.
is innovation. Good.
Please, I have a question.
Go on, sir. Go on, sir. Please
Yes.
unmute yourself and ask your question. Go on, sir.
Okay. Can any of our regular receiver do the same thing?
No, sir. Your regular receiver does not have a geometrically camera embedded on it. Visual photogrammetry has to do with the receiver that has camera. Currently, we have the Oscar Trek and the TS30. So the regular receiver without those camera feature cannot do that. And also, there are still some receivers in the market that has camera, but still cannot do visual photogrammetry. What the camera does alone is just for staking out. When you are going to carry out your stakeout, you just see where you are going to. Those cameras cannot perform visual photogrammetry and point cloud generation. So I need us to understand that they are very different.
Okay, sir.
All right. Thank you, Gospower. Any other
All right.
question?
Hello.
Yes, sir. Go on, sir.
Yeah, this is Victor.
Go on. Welcome, Sir
Yeah.
Victor.
Yeah, if I get you very well, though I didn't start from the beginning of your presentation. How
sir.
do you liken this laser visual photogrammetry scanning instrument with a drone captured image in terms of surveying the building or any other structure? How do you liken it or compare? What is the comparison? How do you analyze to the one to get a clear picture of what you are saying?
Okay, good. In terms of our drone is coming from area. Why this is coming from terrestrial? Drone is from the aerial views, from the sky, capturing the environment. Why this is your GNSS rover that you normally use for survey. But now this one has a camera on board, on the head. Once you hold it and walk around the feature, it captures the same principle of drone, capturing multiple overlapping images, but from aerial view. But this one captures images of buildings or maybe stockpile. And from the stockpile of sand, you can build a model of that sand and compute the volume. So it's still the same principle, but unlike a drone that is flying from the sky, this one you are holding your rover pole in your hand, walking around the feature of interest, and you are able to build the point cloud from those overlapping images directly from your data logger. I don't know if it's clear, sir.
But you know, I get you because the drone is an area coverage, which covers the building or what I'm concentrating. My concentration is on building now, for instance, which covers it directly from the upper view. But this you are talking about, you are standing, for instance, I'm standing on a terrace on a building that is taller than me and my instrument. Now,
Yes.
how do you come to get overlapping of other sides of the building? If I'm on standing, let me say, if I'm standing on side A and now move from side A to side B, from side B to side C to side D, cover the four rectangular side of the building. How does my picture from the instrument I'm holding cover or overlap the other side, since it's not covering the building from the height?
Yeah, so let me like you said, you did not come from the beginning. We actually played the video of how it works. You just walk around, you hold your rover pole and walk around the building. Do you understand, sir?
I'm listening.
You hold the pole and you walk around the building. You take a walk around the building. As you're walking around, it's capturing it. Because of him, let me just play the video again so that you understand what we are saying.
No, Chika, hold on. Before you
Okay.
play the video, it just is a question. Let me, there's something maybe you did not, maybe we didn't factor. Assuming what he's saying, assuming it's a 3-story building. Now, when you are doing photogrammetry stuff, for you to picture, maybe depending on the height of your flight, so that you can able to see what you want to capture. Now, in this circumstance, assuming what is the minimum distance to which you can hold that receiver, so that at a glance it's capturing, it should be able to capture from the down to up to the limit of, I think that's where his question is coming. Because if the
Okay, I think I get that. One, let me also clarify. This will not capture the top of the building like the roof.
Okay.
It's not going to capture the roof. This is between, now depending on the option you're going for, we have an option for 15 meters away from the building.
Good. Now you've actually, that's the point.
15 meters away from the building. Then we now have another one that is up to 50 meters away from the building. So the Oscar Trek is 15 meters away from the building, while the TS30 can go up to 50 meters if it's laser, then about 30 meters if it is just the visual. So that's it, away from the building.
Okay. It's clear now, it makes sense.
Yeah, for the overlapping, you just walk maybe that 15 or 20 meters away from the building and you take a walk around it. As you are walking, the receiver will be automatic. Once you activate visual photogrammetry, it will be capturing the images and transferring them into the data logger at the same time, using the Wi-Fi module of the data logger.
Okay, that's clear. Nice, understand now.
Any other question before we call it a night? So based on the offer we've talked about, you can chat me personally, and the account number is still there. The account number is still there on our screen for you to look at any of the option you're going for. The account number is there. Is there any other question before we call it a night? So with this, we want to call it a night. The video will always be on YouTube. You can get the video on YouTube. With this, we're calling it a night. A night. It has been a wonderful night hanging with every one of us. I want to appreciate everyone for joining. I want to appreciate everyone for joining us live tonight. Let me just do a screenshot. We have, at the peak, we had over 70 persons. Wow. At the peak of our attendance this night, we had over 70 persons live. And I want to appreciate everyone for staying tuned to the very end. It's been a wonderful session, and I appreciate everyone for taking out the time to be here. Let me just do a screenshot. I appreciate everyone for taking out the time to be here live.
So this method, this will help for someone now to, instead of getting a drone.
No, but you know, drone is still
So this is
different. I would say drone is still different in the sense that drone is for aerial mapping. You want to map a very large area, but this one is good for building. For drone, if you want to map a large area, that is where it becomes very useful. But when it has to do with building,
you know why I'm saying it? Because getting a drone and using it, it's also an issue because of licensing and all that. But with this now, it has been in fact, it has been eliminated, so you can do something close to it. So I think that's the whole idea.
exactly, that's true.
That's
That's
the
true.
whole idea. I'm just thinking that I say, well, maybe they just find a way out of it because since the emergence of drone and it's expensive and also to fly it is also an issue. So what can we do? So this is what has come into it now. So what do you call it? Something photogrammetry.
Visual
Visual
photogrammetry. So
photogrammetry.
I would even say for the business of BIM, building information modeling.
Yes.
It might be very difficult for people to acquire laser scanner, but this
Yeah,
one is
exactly.
cost effective. And
Exactly.
most surveyors will be able. Some surveyors, if you have interest, this is much more affordable, I would say, compared to getting a full laser scanner, and
That's
it can
correct.
still do most of the work for you, though not as high precise like a terrestrial laser scanner can be 5 mm. Why
Yeah.
this is still about 2 cm.
Something, yeah.
Yes, so that's the big difference between them.
That's great. Great. Good one.
So I want to appreciate everyone. If it has been a good session, you can just drop a comment and say it has been a good session. If you want us to continue, you can still tell us to continue to have more session. Let me just read it in the comments. I will contact you on how to upgrade my old receiver. That's not a problem. If you want to upgrade your old receiver, we can have a conversation around that. But it depends on the receiver you are looking at. Thank you, everyone, for joining. Thank you.
Merci.
Again.
Merci beaucoup. Merci.
No, I don't share the presentation on Telegram. If you want, you watch the video. The slide is not. I don't share the slide, so you just need to watch the video if you want. But the slide, I don't share the slide. Remember, I said whatever we've shared here. If you want to watch it, you watch the video. The video is on YouTube. You can watch the video on YouTube. So I'm reading your questions. You can drop more questions for us. I'm going to read it there also.
Yeah. Welcome to Geospatial Night, where data meets precision and knowledge becomes power. With the GNSS King. Down to the sky, yeah, we map it all. Satellites above, hit the system called forward and it's locked. Every point precise from Lagos to the world. Yeah, we set price, RTK flow, centimeter dream. Force on the network, tighter than it seems. Leader in the air, scanning every plane. Turning point clouds into insight, getting aerial vision we don't get, we know. Photo imagery, make the model flow. From construction site to the curve, we define. Yeah. Welcome to Geospatial Night, where data meets precision and knowledge becomes power. with the GNSS King. From the ground to the sky, yeah, we map it all. Satellites above, hit a system call, forward and it's locked. Every point precise from Lagos to the world. Yeah, we set price, RTK flow, set amid a dream. Force on the network, tighter than it seems. Leader in the air, scanning every plane. Turning point cloud into insight, getting every vision we don't guess, we know. Photo victory, make the model flow. From construction site to the curve, we define the future. This is how we live here from beginning to end. Got story to tell. From the earth to the orbit, we read it well. Elevation rising, no limit in sight. Get ready for the knowledge, Geospatial Night.
And this thing, and do serious point plan on monitoring, check divisions and all that in buildings.
Yeah, we model the ground, DTM accuracy, got the metrics profound, UAV flights, yeah, we capturing truth from the pixels to the point, that's the power of proof, surveillance, engineers, planners align, oil and gas, agriculture data redefined, smart cities popping with geospatial core, every industry knocking on the data, go from base image to yacht to the skyline view, every day set clean, every output truth, GNSS King, got the insight kitty, unlocking global geospatial mastery. See the world in coordinates. Every line tells the story. From the ground up, we elevate, turning knowledge into glory.
Some of us are still here. Good night, good night, good night, everyone. Have a great night. Have a great night. You can unmute yourself, everybody, and just say good night.
Good night, sir.
Yeah, good night. Good
Good
night.
night.
Yeah, bye.